So in this video, we're going to be looking at writing the chemical formulas. So for the chemical formulas, I'll be looking at notes as well. So here, we'll be using these steps to write the chemical formulas. So I know that step one is identify the electrical charge that each element forms as an ion. So my first step is going to be to identify the charge in the element. So I'm going to write the element. And then I'm going to write the charges also. So if I look on my labeled periodic table, this is a 2 plus. This is a 2 minus. So then for step 2, if the ion numbers are the same, I'm just going to write the elements. If the ion numbers are different, I have to use the cross method. So in this one, I see these numbers are the same. I just write the elements. And ta-da! This will be the chemical formula for calcium oxide. All right, so now we'll go to the next one. This is write the chemical element and its charge. That's always going to be the first step. And I wouldn't skip this step because if you write the wrong chemical formula, it's going to cause problems down the road. So this is kind of like the foundation when we're writing chemical equations. If we get the chemical compounds wrong or the chemical formulas wrong, then when we write out our chemical equations, it's going to really have a drastic effect on it. So I want to make sure that I write the chemical formulas correct. The first step is going to be writing out the charges. I don't want to skip this step. So these have different ion numbers, so since they're different, I'm going to need to use the cross method. So this is a 3, this is a 2. So this is calcium with a 3 charge and with a 2. And the reason we're going to do that is so that the charges are balanced. So with an element that's ionically bonded, we want those charges to be balanced. So let's take a look at it. So this tells me, if I'm looking at just this part right here, so if I'm looking at just this part, and then this would be a different part here. So this is going to tell me that I have 3 calciums. So I know that calcium has a 2 plus charge. And this tells me that we have 3 of them. So that's calcium 3. Calcium 3. 3 calciums. Each one has 2 plus. So when I look on the periodic table, I see that calcium has a 2 plus, and this tells me we have 3 of them. So I know the net charge here is going to be what? 6 plus. Right. This one is nitrogen. So nitrogen, I know that's a 3 minus if we look on the periodic table. And this tells me we have 2 of them. So we have 2 nitrogens. So I can look here, calcium 2 plus, nitrogen 3 minus. Those wouldn't balance if we just pushed them together like we did here. These already were balanced. Since these are not balanced, we need to make sure the charges are balanced. So here we added up these, we got a 6 plus. Here, let's look at these nitrogens, 3 and 3. That's 3 minus or 6 minus total. So 3 plus 3 is a total of 6 minus. So 6 minus and 6 plus, this is the correct formula because I can look and see the charges have balanced out. This step you won't need to do, but if you want to, it's a good way to just check it. I'll be checking them on here as well. All right, so for our next one, we'll be looking at copper 2 oxide. So I know the first step for copper 2 oxide is for me to write the charge. This Roman numeral tells me the charge on the metal. And then for oxygen, oxygen is always going to be a 2 minus. Every single time we is 2 minus. These numbers are the same, so I'm going to push them together. They're already balanced. This doesn't need to be balanced, so it's okay. It's good. Here, one of the big misunderstandings is that this one will be similar. Maybe we'll just add a 3 at the bottom as a subscript. Same process. We need to look at the charge first. Oxygen is always 2 minus. This Roman numeral never applies to the nonmetal. Roman numeral applies to the metal only every single time. These numbers are different, so I know I'm going to use the cross and drop method. So now we have Cu2, and then this is O3. Okay? Then I'm going to look at these as 2 separate things. All right, so I have copper. This is 3 plus. So I know that this is going to be a total of 6 plus where it's charged. We have oxygen is 2 minus. We have 3 of those. Oxygen 2 minus, oxygen 2 minus. So this is a total of 6 minus. Okay, the charges are balanced. So that's fine. All right, so here's our chemical formula. I used the charges, then I did a cross and drop. All right, so now we'll get into the polyatomics and the acids as well. So with our polyatomic ions, get a question? Yeah. So for our polyatomic ions, I'm going to be using the chart. So I always want to go back to the original polyatomic ion. And so my original here is NO3. NO3 is called nitrate. All right. So this would be NO3. These are polyatomic ions, so it has to get the charge. If I just write NO3 with no charge, that's not going to be correct. So this is nitrate, 1 minus charge. Okay, here, this is a nitrate, because I can look at the endings. And I know it's not nitrogen by itself, it has a T. So this must be a polyatomic ion too, but it's going to be different from NO3. So I want to look for the ITE ending. So if I look on my chart here, per ATE ending, ATE. This didn't have a hypo prefix. It only had the suffix ITE. So that means he lost 1 oxygen. So now, instead of NO3, this is going to be NO2 because he lost 1 oxygen. Still has the same charge. Nothing changes with the charge. It'll still be the same. All right, and then this one, I see the ICE ending, RC ending, and it also tells me that it's acid. So this is phosphoric acid. I'm going to go ahead, I want to find the original one. So phosphoric acid, that means originally he was phosphate. And then phosphoric acid is just this polyatomic bonded with hydrogens ionic. So for phosphate was PO4 with a 3 minus charge. And now I have to bond it to something. So this is PO4 with a 3 minus charge. I'm bonding it, so I need to write the charge of this one also. I see that they're different. I'm going to use the cross method. And then this 1 comes outside the parentheses because we have to treat this as one single entity. So that's a 3, and then the PO4 is just by itself. So this would be PO4. I can write the number here if I want to. So this is phosphoric acid. Here I see a polyatomic and just a regular ion. If I look on the periodic table, this is calcium with a 2 plus. Phosphate, I remember that when I just looked at it. That's PO4, 3 minus. Oh, these charges are different. So I'm going to use the cross and drop method. This would be calcium with a 3. And then remember, this 2 doesn't go inside the parentheses. I have to treat this as a single entity because he's a polyatomic ion. He's by himself. He stays together. So that 2 goes outside of the parentheses. So this would be calcium phosphate. Here, I noticed this is calcium phosphite. Oh, we went from ATE to ITE. Let me refresh my memory a little bit. So when I look at the chart, what happens if we get an ITE ending? Okay, he doesn't have the hypo prefix. He only has the ITE ending. That means that he lost 1 oxygen. Okay, that's pretty easy. I got this. All right, so now instead of phosphate, I know that this guy lost 1 oxygen. Charge is still going to be the same. And I just need to write this one, 2 plus. Oh, this is easy. That's a cross and drop because they're different. So this would be calcium 3, and then PO4 3 with a 2. And then that would be how we write the chemical formula for polyatomic and regular metal. So this would be your polyatomic. This is how we'll do the acid. And this is if we have a metal bonded to a polyatomic. You could also have a transition metal. So if we had something like copper 3 phosphate, that would be Cu, and then PO4. Then when I look at the charges, this is 3 plus 3 minus. That would be copper 3 phosphate. All right, and so that's how we write the chemical formulas. Next, we'll be looking at covalent molecules.